So you can use grep. I'm using egrep because that's just using a flag by default there that allows me to do extended regular expressions. And here I'm saying, hey, look at the beginning, find a pattern that matches the beginning of the line, an A, followed by at least one character, followed by an A, followed by the end of the line. And so we've got all these things like autota or abadana. Wow, these are like amazingly obscure words. Atria, atma, astigmia, you know. So there's all these. So we can actually be very. We can be very powerful with these things. What we can't do is what we have trouble with in Python again is, or sorry, not in Python, but regular expressions is anything that requires memory. Or requires us to remember things, previous things that have happened, like counting stuff or matching stuff. Like, you know, that's a bit beyond the capabilities of regular expressions. So again, to use regular expressions, you have to import the RE module, and then you compile the pattern, right? And I compile this, like, here's the Japanese telephone number pattern, right? And you can use parentheses to separate to break your pattern up into groups, right? Here's the area code, and here's the phone number. Actually, this is the American one. So, and remember, when we put an R in front of the string, it means it's a raw string, meaning we're going to look at the string and interpret it exactly as it is, and we're going to ignore all the necessary, you know, having to have escape characters, right? Because if I didn't have this R there, then I'd have to escape all these backslashes, which is rather annoying. Okay. Right. So this will look for the first match that it possibly gets. So let's see. And then you can also, use the find all to return a list of words, right, that match something. Right here we have the Batman definition, right? We left off there, where we've compiled a regular expression that looks for Batman or Batphone or Batmobile or Bat Shark Repellent, right? Well, matches one of those, so we can use or to say, hey, match one of these things. Match one of these options. All right. So, right. So we went over those. So now and we talked about how things are. How in Python you have greedy regular expressions, right? You can how they try to match basically as much as possible. So for instance, here we've got let's see, def greedy demo. Right, we went over this yesterday, where basically we want to match some text and show that it's greedy. So let's go ahead and grab this. Right, so I'm going to grab greedy or ha regex is equal to. We're going to compile this regular expression, which matches 3 to 5 ha's. Okay, and then we're going to search whatever the past in text is, rather than ha 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 ha. We'll search the past in text for this pattern, and that's going to produce a match object, right? And then we can use that match object to do stuff like we can get the group, and we can print that. So, right, I'm doing a lot of printing rather than returning, which is bad practice, but so for instance, if I do greedy demo ha ha, it prints out ha ha ha. And if I do and ha ha ha, it'll just you know, print out the ha ha ha, because that's what it matched there. If I do 4 ha's, it matches 4 ha's. Okay, and if I do 5, it matches 5. It matches 5 of them. Now here's an interesting thing. If I do ha 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 ha, so another 4. How's it gonna? It's gonna do 5. And now if we instead do groups. Interesting. That does 1. All right. Let's see. If we do groups, we'll just do group. Right. It matches 5 of them. It doesn't like it looks for the biggest string of text it can. If I do print find all, let's see what happens. Oh, it has no attribute find all. Right. Right. You have to. That's part of doing the search. So let's just leave. Yeah, let me go ahead and just leave this there for right now rather than doing the group. So, because again, I've rarely used it in Python. What I've done almost all the time is used it in grep. But say though that we wanted to match, like, instead of matching just, right, it looks for, but it's greedy. It looks for as big a string as it can, right? That's nothing too exciting. But say I wanted to look for as small a string as possible. You can add a question mark onto the end, and it will just look for, it'll be greedy the other way. And try to make it as, instead of trying to make it as big as possible, it's going to be lazy and look to basically make it as small as possible. So in addition to the search, you also have find all, which search returns a match object of the first match text. Find all returns strings of every matched every match that's possible. So if we do our ha 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 here, we do instead greedy that find all, and then text. And instead if we print that out, it'll be interesting to see what will happen. So we're matching as small as possible. Interesting that it does, oh right, because I've got it surrounded by parentheses. So it was saying find all will not return a match object, but a list of strings, as long as there's no groups of strings in that regular expression. So that's what's going on there. Each string in the list is a piece of the search string that matches the regular expression. So, for instance, if we did this re.compile, we got 3 digits, 3 digits, 4 digits. We find all the telephone numbers in this cell and work. It displays this and displays this. It will work because, again, it mentions there are no groups in there. And this failed for me because I had groups. If there are groups, then it will return a list of tuples, it says. If each represents a matched object that was found. So it found a ha, it found another ha, and it found another ha, which is not really useful in this case. So if we instead do search, and then mo1 dot, let's see, right, and if we did groups again and printed that out, we're going to get into the same issue where basically we found the first group there, and it found it again and again. We found it one. So the big thing we talked about was having doing character classes, right? That's where it really comes in useful because these enable us to build the more complex things and not have. So we talked about, and the quiz that we just did went over /D/D, right, for digit or not a digit, word, not a word, white space character or not a white space character, right? And I like this one over here, so let me go ahead and boot up idle because it's nice and easy to paste this into console again, right? So if we do, xmas regex is equal to re.compile. What am I doing? I copied it. There we go. So we've got the raw string, Oh, first thing I have to do, of course, is what? If I do this, it says invalid syntax, but import RE, right? Now we do xmas regex.compile any number of digits. All right, so what does this say? Let's just one or more digits, followed by a white space character, followed by one or more words. So if we do find all on this type of text, it actually works really well. Because all of these, everything in here but the commas is essentially matched by the regex. You've got 12 drummers, so that's one or more digits followed by a space, followed by one or more letters. And you've got another one where you've got digits followed by followed by space, followed by letters, and so on and so forth. So these are built-in character classes. The point of the brackets is that you can kind of build your own, like over here, where you can create your own vowel regex, right, just by listing all the vowels. Right, we went over that at the end of last class, right? This one is a regex that basically matches all the vowels. Any one of an A, an E, an I, O, or a U, followed by, or a capital A, E, I, O, or U. If we wanted to match it not a vowel, we just put a caret in front of here. Oh, right, I can't modify that because I've already run that line. Right, that would be for matching anything that's not a vowel. Wouldn't match just consonants, right? It would match anything that's not a vowel, including spaces, right? The other thing that I just pointed out to you was there is the caret symbol at the beginning of the regex, is that it has to occur at the beginning of the text you're searching. So, and that text you're searching, and that kind of depends on your context, because over here, right, in the terminal, when I was going over the words .pdf over here, let's see, do I have grep in this? And let's go ahead and get grep. So go into bash, because yay, Linux subsystem for Windows. So here, if I cd to ITP, cd to classroom, ITP, right? If I look at the words file, right? Oh, actually, that's more. More will let you scroll through it a bit, so less will help a bit there. Right, we scroll through these, and the beginning of the text is at stop of the file, unless you consider the beginning of the text to be each line, which is exactly the case, the default case here. So for example, the regular expression this regular expression over here says you've got to match the beginning of the text that I'm searching has to have hello in it, right? So over here in this case, right, we've got begins with hello. We compile r hello. Okay. And if we search hello world, it will match it. But he said hello won't return anything, so it will say no. Now also notice that basically doing the search over there returns a match object that says it spans from 0 to 5, so it tells us what the indexes are. That's nice. Okay. Likewise, /d, as I was showing you earlier, /d $, says it's a number, and it ends with a numeric character. So your number is 42, it will match that. Your number is 42 all words, it's not going to match that because there's nothing there. And this is a regular expression which says beginning, a number, any number of numbers, end of the line of text. This matches basically anything that's a complete line of letters. Sorry, a line of numbers. So the last thing that I did not go over, because it's kind of dangerous, is this regular expression right over here. It's the @regex. or the wild card, which is the dot. The dot has a special meaning. It is essentially the anything character. And it's dangerous because it's not necessarily dangerous by itself. It's the fact that it's dangerous when you throw it together with almost everything else. So let's look at it at regex. So we're going to compile this. So we're going to find all the things that this regex matches in the sentence. The cat in the hat sat on the flat mat. So it matches cat, hat, sat, lat, and mat. Why does it match that? Well, because you've got the cat, so wildcard AT, in the hat, wildcard AT, sat, wildcard AT, on the flat, so not the F, but it does match the L AT, mat. So now, let's go ahead and try modifying this maybe a bit. At my fat house. So now it will match the cat in the hat sat on the flat mat. And now look at what it matched. It matched space AT. It matched space AT because wildcard will match anything, including the space in front of the at. At my fat house. Right? So the wildcard can be potentially dangerous, especially when you decide that what you really want to do, what you really needed in your life, was to do a dot star, which matches 0 or more of anything. So now let's look at what happens here. This will get interesting, I bet. And it matches the cat in the hat sat on the flat mat at my fat. Which is everything but the last word in the period. Now the reason it did this is because again, it's a greedy it's greedy. Okay, so it went and it looked and said, okay, I want this. You want me to match as much text as possible, boss. Okay, and that's exactly what it did. It said, okay, match anything, 0 or more of it. Okay, so this is anything. This is anything. This is anything. You got an AT here. I could potentially stop, but let's keep going and see. Aha! Could stop here, but let's keep going. Could stop here, but let's keep going. Okay, and then I find out that, and then it finds out that basically this is the way I can stop. This is the last place it can stop. So dot stars can be very dangerous here because they will match literally everything. It's just one character. It'll match just one character. Now, if you want to match the actual dot, right? If I want to actually match an actual dot in there, you know, we need to actually do a backslash character. So if I want to match ellipses, right, it'll have to look something like this. re.compile, right, and the ellipses, remember, is a series of like 3 dots, right? So this would match, you know, this is not in a regex that will find ellipses. It will compile just fine, but it'll match 3 of any characters, right? Ellipses, regex, dot, group, sorry, drop, right, dot, search, actually, let's do find all again. Find all. Hello, how are you? What did I do? Oh, right, it's find all in lowercase. This is what I get from moving between 2 languages. Okay, find all. It goes, hello, how are you, right? It's matching 3 wildcard characters, and then it breaks it up. Now, why does it go HEL and then LO space as opposed to HEL, ELL, LLO, and that? Well, it starts from where the last regular expression left off. So if I wanted to actually find ellipses, you would have to do something like this, /d/d/d, or, you know, 3 of those. So now if I do find all, the script says dot dot dot. So make an awkward pause. Right, and it matches the ellipses there. So matching everything with the dot star. Sometimes you do want to match everything and anything. For example, suppose you want to match the string first name followed by any and all text followed by last name and then whatever's in there. Right? You can do that. Dot star is anything. Right? So remember that the dot character means any single character except the new line, and the star character is every 0 more of the preceding character. And here's where groups really come in handy, because it allows us to separate out the parts of the regex that you are interested about. Right? Over here, we'll compile this regex. Right? Name.compile, first name, last name. So then I'll search name regex dot search, right? And I'll say first name is Andrew, last name Rosen, right? And the object that comes back says, hey, it's an object that spans from 0 to 35, and it matched this. So let's go ahead and print out what we got. Actually, I should probably have stored that in a match object. So let's go ahead and, well, let's actually just call directly. Groups, Andrew and Rosen, right? If I do group 1, right, notice that I'm calling dot search, and then on dot search I'm calling dot star. So that's possibly something I've not really gone into much. But right, so if you remember, this is an object, right? This is a regular expression object. And so I can use dot search. And so regular expression dot search returns a match object, right? This compiles down to a match object, so I can do a dot after that. So I can kind of string these commands together. Okay. So that gives me Andrew. Dot group 2 gives me Rosen. Dot group, and of course group 0 gives me the entire expression itself. So group is nice because you can kind of just look into the whole thing and say, hey, this is the thing that matched. And then the groups are like individual portions that you're interested in. That's really nice. Right? Because if you're running this through lots and lots of text, you're not interested in the first name, last name bit. You're interested in the actual first name that's captured in the group, and the actual one. So the dot star is greedy. It always tries to match as much as possible. If you want it to be non-greedy, which is to match as little as possible, it will. Then you want to use the again the question mark. Right? So here is the difference. So here is, again, their example. I like these examples. So here it's going to match the there's no special symbol for the less than sign and greater than. It means literally find the less than, the less than sign followed by any number of the most you can match, right? The most number of the characters it can match. Well, sorry, any number of characters, but do it non-greedily. So not the most you can match, and then followed by the less than sign. So if we compile this, and we search this regular expression to serve man for dinner, right, that has a, so if we do this, to serve man for dinner, notice that there's two greater than signs. If we do the non-greedy search, on greedy sub, so yeah, I just forgot I just didn't have the N there. non-greedy, it does to serve man, right? Because it says, okay, I'm going to start here. There's a wildcard, 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 and now it's safe to stop. Now I found a place I can stop this regular expression, so I'm going to stop. Right? I found this part which says to stop, so I'll stop. If I do it the normal way, where I do instead a greedy regex, so let's go ahead and just create and grab this, and grab a greedy regular expression, right, and compile it. And we just leave out the question mark. So now let's go ahead and do greedy regex dot. So now we're going to do greedy regex dot search to serve man for dinner. It goes all the way up, right? Big difference between serving man and serving him for dinner, right? Sounds like something that out of a horrifying sci-fi novel. So let's see. So another thing is that the doc star will match everything but the new line character. So so in other words, if I do this, even with the greedy sub regex, if I do over here, it will just go up to serve man because it won't find. It's going to stop at the new line. If I change the regex though and give it an option, re dot all, then it won't care. It says actually the dot should match everything, and it will match everything. Okay, so let's go ahead and review what all the regex stuff that I've introduced you to. And the nice thing about these is that they're almost available in just about in a lot of stuff. So if I showed you that's available in code. Let's see. How many of you have bothered downloading like Notepad++ or Xcode or something like that? Or if you're using Unix, right, it's built into a bunch of the text editors, right? Regular expressions are basically useful almost in every single coding application that you have. But let's review. Question mark is 0 or 1 of the preceding group. Okay. Star is 0 or more. Plus is 1 or more. And exactly n matches. So we didn't go over this n comma with leaving the other side blank. But that means at least, matches at least this many. This means match, if you've got comma this, that means at most this many, right? So let's go ahead and grab this one. Right, let's go ahead and do grep, again, egrep. I'm going to use my regular expression again, and I want to match at least, let's go ahead and do A, E, I, O, or U, and I want to match at most 4 vowels in a row. Right, and it's matching a whole lot of single vowels right over there. So because you saw some 2's go over there. So that's it. So actually, if I want to see anything, so it matches things with 1 or 2 or possibly 3 vowels in a row. But if I want to match anything with 3 to 4 vowels in it, let's go ahead and stop it. Right, we've got plenty on there. So let's see. Then we've learned about the beginning or how to use greedies or not greedy or non-greedy matches. Another big thing is that also sometimes you don't care about the case of words. Windows certainly doesn't. So you can just pass in your compile an re.I or re.ignore case to ignore cases. Like here, I like this example a lot. Robocop.compile. Robocop is equal to re.compile robocop re.ignore case. So if you search this, robocop is part man, part machine, all cop, if you grab it, it'll return RoboCop. If you search RoboCop in all caps, protect the innocent, it'll give all caps. And if you've got search, why does your programming book talk about RoboCop in all lowercase? It will match that too. It matches RoboCop with mixed case, all caps, and lowercase. Now here's possibly what we got into when I was talking about the real big use case for this, which is, remember that we started talking about this because we had a candidate who wanted to run for president and in 2015, and he made a bit of a, and he started his run in, he released a bunch of his emails in 2015, and there was a big faux pas because he accidentally released all of his, basically, he released all the emails that were sent to him, some of which, because he was the governor of a state, meant that it was citizens of that state sending him social security numbers. It's, don't send your social security number, via email unless it's like encrypted or anything. That's kind of important. So here we want to be able to do something like this. We want to match, so agent followed by word plus. So here we want to substitute. Basically, we want to strip out anything, all our agents from the message. So names regex is equal to re.compile. Agent followed by a word character. It's always hard to match these up like this. There we go. So names regex, agent followed by W. So you don't have to do anything special if you want over here to do the substitution. But once you have the regular expression, you can do regex.sub, which is short for substitute. And what we want to do is that we want to use censored, and I'm going to add brackets here. Agent Alice passed me a message. She said Agent Mallory, so malicious Mallory is normally not great. She's normally Alice and Bob are normally nice people, but Mallory is malicious, right? She said Agent Mallory is a double agent! Exclamation point. So now if we end the string, censored passed me a message. She said censored is a double agent, right? Although now I'm reminded of my favorite Onion article of all time, which is that the Pentagon realizes in horror that they've been using black highlighter the entire time. But anyway, so censored. Agent Alice gave secret documents to Agent Bob. Notice that basically it matched any number of word spaces. So it matched up to Alice, and then it found a space. Now, mind you, this isn't perfect, right? Because, if my substitution string was more along the lines of agent, so Agent Alice passed me a message. She said, Agent Malicious Mallory is a double agent. It says censored passed me an agent. She said censored Mallory is a double agent. And now maybe we're just deleting curse words here because we didn't delete the right thing necessarily. So be careful. Read your message, right? Because you also have the first name last time. Sometimes you have the first name, sometimes you have the last name. So sometimes you may need to use the match text itself as part of the substitution. So in the first argument of sub, you can type in /1/2/3 to enter group 1, 2, or 3 of the substitution. So let's look at this. So let's look at this one and see what kind of madness we can use. So here we're compiling it with a group right over here followed by any number of letters after that. Agent, one letter, any number of letters. Now if we do agent names regex, so first off, if I just do sub as I was normally, let's see what happens if I was just doing .sub as I was normally doing it. ASCII table. Let's go ahead and grab an ASCII table. Oh, they don't have the upper level ASCII tables. So let's go ahead and do, right, there's also fun things we can do here. Let me grab this. Oh yeah, why not grab it? Let's go ahead and replace all the agent names with hearts because that's professional. So if we want it, so no problem here. Replace agent Alice is actually the mole. Agent Mallory is being framed. Like we've got the plot of a bad detective novel here, right? And now it will place it just normally. So using groups doesn't really matter at this, you know, it doesn't affect us doing the substitutions at all. Okay. So now though, the idea here is that we can use part of the match text itself, right? So we've got a group here. And so what I could do is I can use the /1 command to grab the first group that we have. And then it says, oh, right, we need the actual regular expression here. It needs the R. Sorry. You need the raw string there because /1, if I'm using /1, then I need to use //1, but so if I put an R here, multiple statements found. Oh, yeah, that's just me being bad at copy pasting, which is like literally my job right now. Okay, so now we look at this. It says, so now we can, now rather than having, you know, this, we can do, watch what we can do now. We can, it grabbed the A from Alice and the M from Mallory, right? Because that was the first part, that was the group that was matched, right? So this might be a bit hard to see here, but it's actually really cool. What we're doing is that we're grabbing part of what we captured and reusing it. So now I can say, I can replace what we have with agent /1. So we're replacing agent, whatever their name is, with /1 ... So now we're only partially censoring it. Agent A, so we censored the rest of Alice, is actually the mole. Agent M is being framed, right? So where are we getting that from? Well, the /1, right? That matches, that's from this group that we used, right? This group is referring to the first thing we captured in the parentheses. All right. Managing complex regular expressions, because these things do get complicated. Regex. So I give you an email, a basic email one on the regular expression. It's not bulletproof by any means. Regex for, oh, yeah, so yeah, we'll come back to that. Regex for email address. An email address regular expression that 99% works at emailregex.com. Just copy and paste it into the language of your choice. Here it is. The general email regex that matches the RFC. So anybody know what an RFC is? RFC is request for comments, which is basically how we basically say which is one of the ways we create standards on the internet. And this is Internet Message Standard Format, which basically designates how email works and like how email addresses work. But this one is, let's zoom in, a horrifyingly terrible regex, right? So you've got, you know, this group managing question mark A through Z, 0 through 9, then also any of these. So what it's saying is that there's you can match, and there's even a flow chart for this, which is terrible. Yeah, that's produced. Yeah. So in regular expression, so it says anything that's not. Sorry, anything that. So let's see. So do we have the matches braces? Anything that begins with our text. It has A through Z, an alphanumeric, a underscore, a dot, a plus, or a minus. So that's a valid thing to start your email address with, apparently. Any number of those, plus A through Z, a dash, plus a period, dot, and then this is supposed to match the dot domains, because there's not just, there's a whole lot of them. So also, Japanese also poses a bit of a problem here, right? So let's actually go ahead and grab our agent name expression again. So this is one of those cases where I actually have to do research on the fly because I know this is an issue, but I don't know how to handle it. Because we've got agent Alice. All right. Let's instead replace it instead of hero. Instead of Mallory, let's do agent hero. One of my favorite names from a book is the main character is called Hero Protagonist. He changed his name to Hero Protagonist. But let's go ahead and type in hero, and I don't know what kanji that comes up to. Don't really actually particularly care for this. Agent hero, okay, is being framed. And now if we do that substitution, I didn't copy and paste the A part. But if we notice here, there's something actually kind of frustrating. Oops. Aside from being stuck in Japanese text. Agent. Oh, interesting. Because I was being told it wouldn't work on those. Interesting. So apparently it does work on Japanese just fine. Good to know, at least in Python. Because when I was looking at your regexer, right? When it's looking for anything that's a word character, let's go ahead and look over here, right? Here's the website, /w. So it's looking for any letter. So if we're looking for, notice it skips over the non-characters over here. So again, it depends on the language on the programming language you're using. So with Python, because Python plays nice with with anything that's not English, it's perfectly fine. So that's good to know. All right. So how do you manage complicated regexes like this? So what you can do is that you can help. So like, look at this one for a telephone number, right? This is kind of scary. I don't want to digest this. It's hard. It looks terrible, right? Right. It's really horrible to look at, even though it matches the phone number. But if you pass in, if you break it up like this and instead use the re.verbose argument, then it will ignore the multi-lines. Sorry, it'll ignore how you split it up into multiple lines. So let's look at it now that it's broken up. It is a area code, which is optional. So it will either have 3 digits or a parentheses followed by 3 digits followed by a closed parentheses. So one of those, optionally, followed by a separator, which is either going to be a white space character, a dash, or a dot. And that's actually optional whether or not they include that as well in America, right? although these days you almost always get the area code. Followed by 3 digits. You always do have 3 digits. Followed by another separator. Followed by 4 digits. Followed by a possible extension, right? They tell you to hit something. And an extension is normally followed by some number of spaces, if any. And then they have extension or X or extension dot, followed by any number of spaces, and then they actually give you the digits. So it becomes easier. And if you need multiple things like ignore case, dot, or verbose, the second argument, you just put the bar argument there, and you can do all those. All right? So I think that's enough to get you, that's basically everything I have to cover for you on regular expression. So we have 2 alternatives now. I can give you time to work on the regular expression stuff, the regular expression exercises I have left for you, or I can get started on how to work with Excel files. And I think actually it might be better today, since I've spent an hour lecturing, to give you guys time to work on the assignment that I've given out to you. And then I'll go ahead and write up something. I'll put up our assignment on the for Excel files.